Hey everyone. And okay. So we have fall break coming up. I think we all always need a day off, no matter when it is. Immediately after fall break, if we could have like a post-fall break, nobody would argue. Same as always, I'll open up the chat box and just let me know if you have anything. Either speak up or type up or whatever, and I can address it if it has something to do with class. So we're going to get more into the p-value today. We started that. Just again, here's what the semester looks like as far as our points. We've done 100 of the exam points. We have 200 of those to go. That's the hardest thing. Everything else is a little bit easier. Easier meaning you get to do it at home. There's nothing else that everything's at home. It's quarantine, but you get to do it without a time limit other than the eventual due date. It's not like a shot clock in basketball that every 24 seconds, right? You're moving along. But the executive summary, the CD cert, and the IRB forms, we'll go through that. Again, the executive summary, how to write it up. You just start with the title. Everyone turns in one. And so your name, and then the associated investigators would be your partners if you have partners in your poster. Have these be your little subheadings, a few sentences for each one. It's a one-page assignment. Make it good. It's a one-page assignment though. And the objectives, hypotheses, and you're done. But again, with the writing, just don't waste any words. I think I likened it last time. I described it to a buffet where you don't want to fill up on sticky rice. You want the good stuff. And the world is that, right? You go to Netflix and you spend a lot of time scrolling because not good enough, not good enough, not good enough, not good enough. Doesn't look entertaining, doesn't look entertaining, doesn't look entertaining. And as a professor, I have to grade everything. I have to read everything. It's the equivalent of you open up Netflix and you have to go one at a time. Every single thing on there, you have to watch them all. And so many of them are just agonizing. Like, all right, I have to watch this with intention, right? The budget was $100 and they made a show. And so make sure the writing reflects the quality. In the real world, the product you give somebody, if it's not really, really good, they don't want to read it. They don't want to do it. You write entrance essays for things and people hate reading those. So you have to be really good. You have to be better than all of your peers at it. There's this thing called masterclass. The name is fine, but it's a little bit stupid because you're not getting a master's degree. But they got all these famous writers and famous musicians and famous culinary folks and whoever, actors and videographers and photographers. There's all these famous people that got together to give these speeches, and they subdivided those speeches as though they're 20 separate lectures and each one's like 5 minutes. But this is David Sedaris. I mentioned I think it was in this class. He's one of my favorite writers and one of my favorite living writers. And in his masterclass, he says, give your editor draft number 20. Do not give your editor your first draft. It'll embarrass you and your editor will think you're a terrible writer, and nobody can give their editor the first draft. And so never give a professor or anybody who's going to grade anything your first draft. And I just took some screenshots, and he says 9 times out of 10, my only comment to people, where people are coming to David Sedaris for literary advice. How do I write? How do I improve my writing? How do I make my writing readable to other people? And he says 9 times out of 10, my only comment is you need to rewrite this 60 times. I mean, 60. That's his thing. Once you're a serious professional and you've been doing it for 20 to 25 years, 20 rewrites, 25 rewrites, something like that might be sufficient. But he's like, you know what? Nobody wants to hear that. Nobody wants to hear that advice. But writing is rewriting. Writing is not writing. Nobody bangs it out in the first draft. That doesn't happen. And there are rumors of people who are like, oh, this person kind of wrote at the pace of typing. It's like Christopher Hitchens or something. Some of these old people, these rumors. I sort of even doubt those are true. The rumors of the legendary writers who could do a first draft. I don't think so. That's like saying Michael Jordan never practiced. So it's just rewriting and rewriting and rewriting and rewriting rewriting, editing, 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 editing. And if you don't enjoy the process of editing, imagine how much pain your reader will have in reading an unedited thing. Like if it's not interesting enough to you to edit and to revise and to rewrite, then it's going to be even less interesting to your reader, because this is your thing, right? So your reader is going to find it even less interesting than you do, no matter what it is. If you're writing a song, your listener will find that song less interesting than you do, right? Because it doesn't register with the same emotions, because they didn't put in the work. It doesn't have the same internal dialogue. If it's a painting, no one on earth will like the painting as much as you do. Whatever it is, nobody will like it as much as you do. And so if you don't like your writing enough to edit it and to revise it, and it's too boring to reread it, that's pain in your readers. And probably the only real lesson that everybody from this class should take with them: statistics, take it or leave it. It depends what profession you want to go into, but the ability to communicate in a way that is clear, that is marketable, that is interesting and hireable. I mean, that's the most important thing you can learn from college. Okay, so CD certification, just do it, right? It's due at some point. You just click there and make sure you don't pay for it. The IRB forms, right? Go to the additional materials. There's a little thing for the IRB forms. And if you want to go to that CD instructions, that's how to register. But the IRB forms, you can go there. And again, you don't have to unpack this zip box, but this is everything you would need. Either the existing or the human subjects, one of those two, and then the matched one of these, so you can see how other people have done it that have been accepted. So that's those three things. That's 30 points right there. The poster and its presentation. Now, this is the culmination of the semester, but if you're thinking about it now and you want to start preparing in advance, if you go to the additional materials final poster project, if you go there, you'll see this. So this is up on Canvas, and that's the rubric. If you want to see how it's graded out of 100 points, that's the rubric there. Now it's difficult to grade it exactly according to the rubric. No rubric is perfect unless it's a multiple choice test. Because sometimes things, depending on the nature of a project, you might not have a particular domain that's graded in the rubric, and so I'll assign points elsewhere. So there's a little bit of malleability in the grading, but this is a skeleton of what the grading would look like, and then there's some sample posters, stuff like that. All right, we're there. We have a little bit of time left to go before anything is due. October 9th, that's lab 1, and the research topic, get that in on October 14th, and then lab 2, October 16th. So due dates start to pile up. If you wait until the last day or two before the due dates, you'll realize you're swamped and overwhelmed, and man, this class is hard. When it shouldn't be that hard, right? Because if you do your work along the way, if you sort of protect that process every single day, you do, all right, I got 30 minutes epidemiology to do outside of us talking, outside of me talking, and then at the end of class, some people chatting. Outside of this little period, if you do, all right, I'm going to do my 30 minutes every day, you'll wind up with an A in the class. I mean, if you just do it every single day. Do we do the project in groups? I will talk about that in just a couple of slides. The answer is yes, you can. And I'll show you that in just a second. But make sure that process, no matter what you're doing, if you want to be an athlete, right, you don't do all of your training once a week or something. You're not going to be a good athlete. If you want to be a writer, you don't write once a month. Like, oh, I want to be a writer. Okay, well, are you doing it every day already? Then you never be a writer if you're not doing it every day. I want to be a musician. Okay, what's the last day you took off? If your answer is like some religious holiday, fine. If your answer is, a couple of days last week I did, you'll never be a musician, right? And so it's the same thing for being a student. You just have to do studenting every single day. Whatever it is, it's the process that gets you there. You'll have good days, you'll have bad days, you'll have days of studying where you don't learn anything. What a waste of time. Okay, maybe it was a waste of time, but if you do it every single day, don't wait for what people would call the muse to come strike you and start rubbing your shoulders and get you ready. Just the process is only about the process. That's the only thing that matters. In the end, read every memoir everyone ever says, and if they're honest in that memoir, it's the process. I just make sure I do it every day. I get up a little bit early and I make sure I get a couple hours a day. That's all anybody says in these memoirs, no matter what profession it is. Even the musicians who people think are just lucky or born that way, or not even close to true. None of them are. So it's just, again, the process. And if you do that process for class, you do your 30 minutes a day, it's not going to be that hard. If you wait and procrastinate And prerendenate would be even more procrastination. Then that's delaying. Why do tomorrow what could be done the day after tomorrow, right? Let's do some extreme procrastination. Then you'll never actually, it's difficult to get the grades if you do it that way. But if you just study every day in every single class, it's bio, it's chem, whatever, the grades follow. So the poster projects, yeah, it's at the end of the semester, but semesters happen fast. We're on lecture 14, and sort of to me, it feels like this thing just started, and we're on lecture 14. And once we get to the poster presentation part, it's going to be all digital. Normally, we print them out. You normally print out these little posters, and you stand in front of them, and everyone in the class grills you on questions, and you answer them to the best of your ability. And I just sort of watch and grade people's question answering ability and the question asking and but now we'll just do online. So everyone, you just do like a share screen and put your poster up and walk everyone through it for 5 minutes next. And we get the next group to go. But once we get to the posters, I'm hands off, right? I'm hands on right now. If you have statistical questions, Nathaniel is hands on. I'm hands on the computer, and I can walk you through stuff and explain stuff. But once it gets time for the poster, then it becomes an individual project, individual meaning your group. You can do it one student at a time. That's fine. If you're like, you know what, I just want to do my own thing. I've already started this idea, and I don't feel like trying to distribute it among people. Every time I go driving and see a construction site, there's one person in the manhole and 6 people eating sandwiches, and I know I'm going to be the one in the manhole, and I'm going to be bitter about the sandwich eaters. Whatever your reasoning is, or if it's just something that like you don't want to organize, I don't want to organize stuff with people. One is fine. You can do a poster project of 1. That's fine. You can do 2, you can do 3, you can do 4. You can't do 5. There's no exception. Like, well, but we're quintuplets, and we all came out literally at the same time. Ripped mom up on the way out. There's none of us came out a second before the other, and we've never. We're all conjoined, right? And we do everything together. Okay, you're gonna have to figure out a way to divvy that project up. So no 5s, 4s, fine. 3s, fine. 2s, fine. 1, fine. No 5s. If somehow you're like 3.5 people or something, fine, whatever. Just make sure your posters are practical and meaningful, right? That your questions are interesting. If they're interesting to you, you can make them interesting to other people. Anything that's interesting to you can be made interesting to other people because you have a human brain. We all have the same emotions. We're all a bunch of people. Right. And if you look around the world, it's not us v them stuff. It's just we're all a bunch of humans with the exact same organs, more or less. Let's ignore the sex organs, with the same tissue and cells and biological systems and the same hormones and the same receptors, the same sort of cast of life experiences, more or less. We all experience the same things, feel the same things, think in relatively similar ways. That's why psychology gets to be a field. And if something is interesting to you, I promise it's interesting to other people. Nobody is actually unique in the world. Where there's 100 million Courtneys out there, and I mean, I think there's like 3 in this class, but that's just, by name alone. But by personality and by the way that we sort of move through the world and think and plan and execute, we're all a bunch of people. Everyone's a bunch of, there's tons of you in the world. There's tons of me in the world. If you think something's interesting, all it takes is work, and other people will find it interesting. If you find something interesting and nobody else does, it's your fault. You're explaining it badly. You're not putting in the work ethic. You're not giving your topic its due, and it's your fault for not communicating in a way that might ensnare a listener or a reader or some sort of audience member, right? It's up to you to express how this is interesting. Again, I come back to this about every other lecture, but Pokemon, I've never played Pokemon of any kind in my life, and it was the most fascinating poster. You can tell it's fascinating because I've talked about it like 6 times this semester, and it was so good because Pokemon was super interesting to them, and they put time into it, they put work into it, and they explained it in a way that was interesting to somebody who's never played the game before. The cards or the video game or whatever. It's a great reference, Pokemon, but I know nothing about it. And so to me, it's like, here's egg type Pokemon, and here's steak type, and I don't know what these things are. Now, the due dates, October 12th, 12, whatever, get your groups chosen by then, because you're going to have a couple of days to figure out your titles. Now, I'm not holding you accountable for points of getting your groups you don't have to send me who your groups are on the 12th because you'll tell me who they are on the 14th. But if you come up with what your group is on the 14th, and then you're trying to come up with your question and sort of negotiate that with your group members and stuff, that's not pleasant, and your question is going to be stupid, right? So you need a little bit of time to talk about your question. Otherwise, I'm going to roll my eyes and ears and any anatomy that's capable of rolling. I'm going to do that at you if you give me a terrible question. And so have a couple of days to think your question through with your group. Now, if you're an individual, you don't need to pick your group, right? It's not me. But if you're going to have some group members, make sure you discuss it with them. And then October 26th, every individual group member writes their executive summary. At this point, you should have read a meta-analysis or some sort of systematic review and been able to identify the gaps in the literature. Otherwise, you can't really write an executive summary. But so October 14th, submit me your poster titles. Those poster titles between the 14th and 26th can change, right? People might do a little more reading and say, hey, what do you think we go in this direction a little bit instead? Totally fine. But at this point, this is your outline. If you're going to write a novel, you write an outline first. If you're going to write any type of book, you're going to write some nonfiction book, you write an outline first. You spend an enormous amount of time on the outline, and that saves time later. The executive summary is your research outline. Okay, so poster topics, again, the purpose of the exercise is to discover something. It doesn't have to be magnificent. You're not going to win a Nobel Prize. If you do, I'll be stunned that a month and a half worth of research earned you a Nobel Prize. I'll start to question the authenticity, or you're a genius, and that's even better. And I hope that happens. So, but what I don't expect is some world-changing finding. I just expect something interesting, something novel, something interesting, something with a little, oh, we found significance in this little thing. We can answer this question, and it's novel. Let me tell you why it's fascinating. And there's like a little anecdote, and it's wonderful. Those are the best things in life, are a little anecdote. Something you can put it in your pocket, and you can bring it up in a sentence later. Actually, and overturn what someone was saying. So the purpose is to discover something new. To do that, you're gonna have to do SPSS. Somebody in your group is gonna have to do some SPSS analyses, and ideally everybody. But if you have a group of 4, okay, one of you is going to be a better statistician. One of you is going to be the tallest, even though you're almost all the same height. One of you is a tiny bit taller. One person has the longest fingernails. One person has the biggest shoes. Somebody's going to be best at stats. Fine. Ideally, you're all familiar with this, and you'll demonstrate that in the labs. But we've seen this before, right? This is a regression output from SPSS. This is everything it gives you from a multiple linear regression, and the stuff that you focus on, again, these are your independent variables or your predictors. If you're talking about a regression, it's actually a little bit better to call them predictors, but independent variables or predictors. And the only reason I say predictors as a matter of nomenclature is a little bit more preferential is they aren't really independent of each other. Entering GPA and how long you spend studying, these things are probably correlated. Now your 989 is probably that's an independent variable. I doubt that's related to anything. Maybe it's related to age, right? Because you get these 989s in a sequential order, and maybe the older students have a smaller 989. All right, fine, right? But entering GPA and duration you spend studying, that might be correlated. So they're not really independent from each other, but independent variables predict your dependent variable. And that nomenclature is totally fine. Or if you want to say predictors, it's just a tiny bit better, but it's not necessary to use a tiny bit better. You can call them independents, you can call them predictors. And this is your outcome or your dependent variables, exam points. Remember, the R squared is what percentage of variance in your outcome, in your dependent variable, can you explain by your collection of predictors? And 35%. Overall model is significant, and this is the individual significance of each predictor. So entering GPA with each additional point that's in a regression, they put it into the units of measurement of each of these. So duration is in hours, 99 is in 99. I put this in here because it should be gibberish, and lo and behold, it's gibberish, right? It's a way of showing, okay, this isn't just some weird analysis. So, but if this was something I were publishing, which I'm not going to, but if this was something I were publishing, I would get rid of the 99 because it is gibberish, and you don't want gibberish in the model. The reason the R squared dropped a bunch for the adjusted R squared is this 989, right? These are both significant. This one is significant when the 99 isn't in there. It's we'll talk about what a 0.051 means today. It's actually nice to see this because we'll talk about what 0.051 versus 0.049 means when we're talking about p-values. But let's use a 0.051. For each additional hour you spend studying, that's what this duration one is, each additional hour you spend studying, you expect your exam percentage points to increase by, approaching a fifth of a point. P equals 0.051. So if the null hypothesis is true, meaning duration you spend studying and your exam score have nothing in common, nothing to do with each other, they are not correlated in the least. Study all you want, study as little or maximally as you like, and one has nothing to do with the other. That's the null hypothesis. If the null hypothesis is true, there's only a 5.1% chance that we would have observed an effect this big or bigger. That's what the p-value means. So remember, as you're doing your background searches, Michelle Maloney, but don't run up to her and say, do all of my work for me. Get as far as you can and then approach her and say, here's what I have, here's where my roadblock or the hurdle that's a little too high, or I can't translate this thing, or I'm trying to do these searches and like nothing's coming up. At that point you go to her, but don't go to her like, tomorrow and say, give me all my work. She'll hate me actually. Like, why are you sending these terrible people to me? These people are assholes and it's your fault for making them that way is what she'll think of me. She won't actually think that because she's such a sweet person, but you get the idea. You don't want to do that to people in life. You want to do as much work as you can to minimize the work on other people. Let's go back to David Sedaris for a second, that author who said, revise 60 times as the advice he tells people. And one of his essays, he talked about being up in a hotel room. I mean, this is somebody who has like 10 New York Times best-selling books, and somebody gave him a birthday cake, and he doesn't have a knife or a fork, any type of utensil, but he doesn't want to hassle people. He doesn't want to burden people. And so he pulls out a credit card out of his wallet and cuts the cake with a credit card and uses his credit card so he wouldn't hassle the desk clerk. Oh, could you bring me up silverware? Burdening people is such a terrible thing in life. I mean, that's, we can say drive-by shootings are bad. Okay, good. Yeah, burdening people, that's up there with drive-bys. I mean, it's one of the worst things you can do to somebody. So if you hate people, load them up with unnecessary burdens. And you can kind of giggle about it later that night. If you respect somebody, don't do it. I mean, man, it makes people hate you. And so be a David Sedaris about things. Cut your cake with your credit card if you can to avoid burdening people. Now, like if you can't even get into the box, it's like, I need a box cutter to get into this thing. Go to Michelle Maloney, right? She'll give you the box cutter, she'll help you out, and she'll springboard you into the future with all this productivity, right? So get as far as you can, and then, go get as far as you can, and then go, add the clearly the link works. I don't know if my screen share, if it just stayed on the thing or if it showed the library webpage coming up, but go to those links if you want to locate Michelle Maloney, but get as far as you can first. Don't just hand her an open package and say what's in it. So PubMed, right? So if you're going to do any type of scholarly searching, Google is okay to get started. Wikipedia is honestly okay to get started. PubMed is the best place to finish that process. And to evaluate the quality of a journal, the impact factor, Thomson Reuters, the impact factor, really useful way to see if the journal you're reading is of scholarly value, if it's reputable, if other people cite this, if other scholars cite this work, and thus you should cite it too because others do. Just remember, there's a ton of fake journals. I'm not going to go through that exercise again of showing you all the weird solicitations of hilarious grammar errors, but there are as many fake journals as there are real journals, and so it takes some amount of caution. Again, they're burdening you. This is my issue about burdens, right? These fake journals burden you because now, instead of searching and just all information is good, you have to wade through oceans of crap to get to the corn kernel or whatever, to get to the thing you want to use. You have to do so much waiting, and it's such a waste of your time. Imagine what you could be doing with that time. You could be napping with that time. What a wonderful, expensive time to go take a nap, but you have to wade through other people's burdens, right? All these fake studies and everything. So SPSS, right, you're going to use this a lot. Scale, these are your dependent variable in a regression will be scale. Linear regression will be scale. It'll be nominal if it's a logistic regression, but we'll talk about that later. Now this is exam scores from last semester. I do the same thing every single semester. I analyze the exam scores and I try to figure out what predicts performance. And I tell you, here's what predicts performance. Please go do this for your next exam. And the people who do it always go up because I code for that too. Now, this is a weird semester because it's COVID. You can't go to the tutoring office. You can, call up Nathaniel and stuff. But so I didn't code for tutoring this time. But last time, holding sex constant, tutoring, I didn't code for GPA last time. That was, I had to look for something else. I'm like, okay, we're not doing tutoring and stuff. So I got to figure out something else to use as a predictor. But last semester I coded for tutoring. People who did tutoring scored 13 percentage points better on the first exam. Females scored like 10 percentage points better too. But this semester, it was males and females did the same. Last semester, it was, I think I had some ringer ladies folk in the class, and the guys were maybe a little bit lazier last semester on the first test, and by the end, maybe it had steadied out. But certainly on the first test, holding sex constant, tutoring associated with a 13 percentage point increase in the exam, P is 0.043. So, just remembering what significance means. Your R squared, percentage of variance you're accounting for, the significance, collection of the predictors, the whole model. But the significances that really matter are these two, individual significances of the individual predictors. So this is where we left off. We were talking about null hypotheses, meaning nothing's going on. Depends on the experiment what nothing means. Nothing could be a lot of things. It could mean two variables are not related. It could mean one variable doesn't affect the other. It could mean there's no change from beginning to end. This supplement doesn't work or whatever. This drug doesn't do anything, or it just means nothing. The null hypothesis means nothing. Whatever you're expecting to find, you didn't find it because there's nothing. That's the null hypothesis. Now, a type 1 error, remember a hypochondriac, type 1 hypochondriac. There's nothing there, and yet you're finding it. Your experimental conditions have elicited a finding, a statistically significant finding, and yet there isn't one in the real world. Vitamin C is not going to I don't know, like cure leprosy, okay? And some experiment finds it. Oh, just have rose hips and leprosy goes away or something like, okay, that's a type 1 error if the experiment actually found that. That was a stupid example, but you get the idea. Type 1 error is you find something, so you reject your null hypothesis, meaning the null hypothesis is false. The null hypothesis says nothing is there. I found something, so I'm rejecting the null hypothesis. Yeah, but in real life, there's nothing there. Your experiment was just messed up, right? Your experiment failed. That's what you found is error. Type 2 error is the opposite, right? There actually is something. The lazy detective down here, there actually is something, and your experiment failed to detect it. It failed to elicit it. It failed to find it. So you accept your null hypothesis and say, nah, nothing's there. But there is. In real life, there is something there. If some drug cures some condition, but your experiment didn't find that, p-value of 0.6, the drug doesn't work. Well, no, it actually does. You ran the experiment wrong. Or you sampled wrong or something like that. So again, what the p-value is telling you is if the null hypothesis is true, always begin with that. If the null hypothesis is true, and you found something, right? If you found an effect, P is 0.03 in this case, that means there's a 3% chance that you would have observed that, you would have found that, your experiment would have given you that output. Or something more extreme than that, if the null hypothesis were true. So always begin, if the null hypothesis is true, then there is only a 3% chance that I would have observed what I did or something more extreme than that. And something more extreme than that is critical. Don't say there's only a 3% chance that I would have observed what I did. There's a no percent chance you'd have observed what you did. Just like you step on the scale and it says 100 44.3825218931482 pounds. Whoa, this supplement causes exactly that much weight. What are you talking about? No, it's that much weight loss or more than that. That's what the p-value is telling you. And so, or more extreme than that, or of a greater magnitude than that, however you want to phrase it, that is critical. Otherwise, your p-value is incorrect. If you don't add this to the end, what you're saying is a hilarious lie. And we could talk more about the mathematics of that lie later, but this is critical and this is critical, right? If the null hypothesis is true, p-value percent chance that you would have observed what you did, or something more extreme, or something of a greater magnitude, something larger, something more negative, something whatever, something more extreme. Remember Steven Pinker? This is the guy who said, the odds that crop circles are created by aliens. That's not a mathematical question. I'm not going to ask about Steven Pinker on the test. Some point in life, read David Sedaris, read Steven Pinker. These are great people to add to your, what people will call a bucket list, whatever stuff to eventually do when you're done with school and you're not sick of reading. Great authors, but the McCann Erickson advertising campaign, for everything else there's MasterCard, right? That priceless campaign. Remember, for everything else there's a p-value. Not everything can be described by statistics, but for everything that can, we add a p-value. It's the most ubiquitous statistic you're going to encounter, and you have to be able to define it. You have to be able to understand it. You have to be able to report it ethically and honestly and meaningfully. So we'll go through some rules for the p-value. It's a good article, this one, if you're curious in this stuff. Seminars, that's not a good way of spelling seminars. But if you're curious in this stuff, then read these articles. If you want to work in this field, read these articles. If you want to get through the class and maybe you're a little bit interested, don't bother, right? But if you think you might be interested later in life, just write them down at that point, or save the lectures. So if you get a compelling p-value, 0.03, 0.02, 0.01, 0.05, 0.08, I would say, that's encouraging. That's really good. It's not the end all of the conversation. You found that once, right? So you don't state it as a fact because you found it once. It's encouraging. You should be encouraged to repeat the experiment, to test again and say, hey, I may be on to something. Okay, so a p-value of 0.05 means the null hypothesis has a 5% chance of being true. Totally false. Right now, this is what people say. Usually people come out of an undergraduate research methods class or stats class, and this is how they phrase it. And I'm sure the professor knows better, but it's just, it's too much work to explain to him what a p-value really means. Let's just say it's a 5% chance of being true. I know a lot of people will do that because it's out of laziness. Don't do that because it's totally false. So think about flipping a coin. We know this is a 50-50. You flip a coin. It's a 50-50 chance. Okay, flip a coin. You can run this experiment. Do this experiment, enter it into SPSS, and run it. This will illustrate the point better than doing the experiment yourself will illustrate the point better than my words will. Get a quarter. Use your right hand. Flip it 20 times. Write down the sequence of heads and tails, heads and tails, heads, tails, 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 heads, tails, whatever. You get to 20 and 60% of them are heads. Now do the exact same thing. Flip it with your left. Heads, tails, 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 heads, tails, tails. You get like a string of heads in there. Heads, or whatever for some reason. Now we know the odds are 50-50. I mean, that's a fact, and we know that fact. Your p-value isn't going to confirm that. You might get a p-value that says like 0.23, that your right hand and left hand are different. A p-value, are the right hand and left hand different? Well, assuming the null hypothesis is true, that they're the same, there's only a 0.23 p-value, a 23% chance that we would observe something as different as we did or something greater than that. So there's a 77% chance that the null hypothesis is false. This coin, my right and left hand flip differently. Not true at all, right? So stats can be abused. And we'll talk about that today. Stats can be abused. So we have to understand what the p-value actually means here. And just because a p-value is above 0.05, it falls within the rejection range. It doesn't fall within the rejection range. Not helpful sentences. That's how people talk. Not the tiniest bit helpful. It doesn't really give you any information. A 0.052 means there's a 5.2% chance you would observe something as big or bigger than you did if the null hypothesis were true. A 0.957 means there's like a 96% chance you would have observed something this big or bigger. There's really nothing going on over here unless you ran the experiment horribly, collected data terribly, something like that. And so both of these, neither are classically significant, 0.05. They're both above 0.05. So neither of them is actually, quote, significant, but they mean totally different things. I mean, these are different worlds over here. So just because something doesn't fall within the rejection range, that doesn't mean you don't have a paper, you don't have an abstract, you don't have a sentence to say, a poster, an interesting finding. The p-value means something. The range is what lazy people who don't understand statistics do. Reporting what that p-value actually means and the nature of the experiment and the nature of the finding and the statistics that correspond to that finding, that's meaningful, that's interesting. A p-value of 0.1 could be the most interesting finding in the world. Right? Yeah, we wouldn't even consider that a trend. We consider really 0.08, 0.05 to 0.08 is what people classically call a trend. Not significant, but a trend. 0.08 to 0.1, 0.099, people say a weak trend sometimes, or they'll just throw those out. You get above 0.1 and people just ignore those findings, and I do a little bit too. I would like to report these and say, hey, there may be something fascinating here, but you get to the peer review process and people start to frown at you. Again, in the peer review process, at the end of this semester, you will know more than most peer reviewers. You will know more than most published authors. You will know a whole lot less than professional statisticians and epidemiologists and some people in health and exercise sciences. But you'll know more about statistics than, I don't know, more than 99% of all physicians. And there's a lot of physicians who are peer reviewers. And you'll get some hilarious feedback in the peer review process if you go through this. And you can tell when they're physicians because they don't know anything. Now, they know way more than I do about prescriptions and signs and symptoms and particular disease states and certainly surgery. And there's domains of a physician's practice that I'm a child in comparison of. I can't even, I don't have 1,000 medications memorized and the pronunciations and doses and oh, this sign, this symptom, this dose, take it. I don't know any of that stuff. And to the same extent, the physicians don't know anything about science. They don't know the tiniest thing about statistics. Now, there are a lot of MD PhDs. That's something that exists in life. You'll see MD PhD where they have both degrees. Okay, those people know a lot about science and statistics. But the peer review process, right? You select a journal. You prepare your manuscript, you submit your manuscript, you go through the peer review process. It's usually 3 peer reviewers. I'm a peer reviewer for several journals, and I rarely accept on the first draft. Sometimes I just outright reject and say, okay, sorry, this just isn't appropriate for this journal, or like, this is hilarious that you try to do statistics on 3 people or something. But usually I'll say, okay, there's something here, but you need stronger statistics. You need to readdress your question because your stats don't actually address your question and you're coming up with conclusions that aren't supported. And so I'll give them a bunch of feedback and say, revise and resubmit. And then they just resubmit to the same journal. And if they address what I said they would, then I'm like, all right, you have my stamp. But you reject and so you pick a different journal. But your peer reviewer process at the end of the semester, if you pay attention and learn and then you're interested, I'm not saying you have to know these things any more than you have to know art history or if you take like music theory or you take chem or whatever. You don't have to know anything about the labs. You figure out what you want to know in life and learn it. But in this class, if statistics and science and how we know what we know and your role in contributing to that knowledge is interesting to you at the end of the semester, you'll know more than the bulk of all published authors and doctors and stuff. So your phrasing should honor clinical relevance in the way that you phrase things. Remember, this all came from Fisher, from Ronald Fisher, and he's just been the most impressive statistician who's ever lived, and he used 0.05, so nobody else has ever been smarter. So we just say, okay, we'll use 0.05 too because you did it and you're the smartest one, right? So we're sort of a bunch of copycats. But he didn't adhere to 0.05. He just said, well, if no scientific worker has a fixed level of significance from year to year and in all circumstances that you reject hypotheses, meaning 0.05. He said, 0.05 is not a law. Right here, these are his words. 0.05 is not a law. Give your mind to each particular case in the light of evidence and ideas. And so honor what the p-value means. don't offend people who don't understand p-values. Peer reviewers often don't understand p-values. You'll find it's hilarious. But so you want to adhere to some of that rigidity, but you also want to be a human being, an understanding human being who gets science and understands the meaning of these findings at the same time. So p-values of 0.0499999 and 0.050001. In the peer review process, often this finding will be rejected. They'll say, nope, that does not fall within the rejection range. This one will be accepted. I mean, we're talking like half the time. This is the difference. These are the same number. Okay, this is like if you win the lottery, okay, and you win $1,000,000,75, okay, or you win $1,000,000,000 and no cents. You file for bankruptcy on the exact same day, at the exact same moment in the same casino, right? It doesn't, that extra dollar, the extra $1,000 you get on that billion doesn't matter, right? It doesn't matter the tiniest bit. It's the same amount of money, $1,010,000,000 or $1,000,000,000. It's the same amount of money. It really doesn't matter. Nothing ever changes in your life. Nobody could ever tell the difference in your life with that $10, right? So it's the same number. It means the same thing. Like, are they technically different? Yeah, sure. Letter of the law, fine. Spirit of the law, no. These are the same number. And yet, about half of peer reviewers will reject this finding and accept this one. So be smart about this, right? You want as low of a p-value as you can get. That's real statistical probabilities, the lowest p-value you can possibly get. This is one of the people I admire most on campus. This is Bill Heron. He's the director of the School of International Studies. He's an economist by training, and literally taught all over the world. I mean, he taught for semesters in Uganda. I mean, this is the most experienced person you'll ever meet if you can take a class with Bill Heron. A wonderful teacher. But one of his lines is, he sees economic statistics and he just goes, oh, come on. Like, yeah, you got a p-value, but did you think about your question? I mean, it's the coin flip thing. My right hand and my left hand are different. And what Bill would say, does it pass the Snicker test of like, oh, come on, that sort of response to a finding. This is a valid question to ask everything. When someone comes up to you with a finding and says, oh, the p-value, I reject the null hypothesis. You're like, but come on, though, this is so absurd. You flip the coin with two different hands. Remember the jelly belly thing? Green jelly beans cause acne. Yeah, but you tested 20 different jelly beans and your p-value is 0.05, which means 1 out of 20 of them is likely to elicit random significance, right? The Snicker test, right? That's what that means, is be a thinking person about all this stuff. And so don't just talk about things are significant or not significant. Report the actual findings here. I was a reviewer on a paper once that looked at, I was actually reviewing in someone else's name, but it was on a paper that looked at a weight loss program, and they said it was statistically significant weight loss, and it's for diabetics. And I'm looking at the stats, and I had to really dig up the stats. It was on a totally different page of like, what are the findings here? They're just telling me it's a significant weight loss experiment, and that people should do this behavior or something. And I had to dig to figure out and like run the numbers myself and figure out that people lost, there was like 20,000 subjects. Now everyone on average lost like 0.02 pounds. A bathroom scale can't even detect that. You stand on the scale, you don't even see it. So they have like a medical grade scale, but they found significance. That's not significant. That doesn't mean anything. Okay, technically, yes, it's totally significant, but it is not meaningful. It is not practical. There's no magnitude that is worth considering. A 1/10 of a pound of weight loss, a 20th of a pound of weight loss, whatever it actually was. I don't remember the real number. It was tiny though. And that doesn't change anybody's diabetes. That doesn't change anybody's kind of neural functioning, right? You're not going to ward off distal neuropathies or retinopathies because you lost a 20th of a pound, right? But significant, move away from that. Like, explain things like a real person. Now, people will say 0.05. Well, that's because biological variation is about 5%. And this guy didn't say it. I just put that quotation against his face. But people will say that 5% biological variation, so we have a 5% p-value. That's not. The people just made that up. That's not true. No, it could be certain things do have about 5% variation. Certain physiological phenomena do have a 5% variation, or sometimes it's 1,000% variation, or no variation at all. Right. So, I mean, if you're going to do a number of testicles, right, if you're just looking at men, you're pretty close to 2 for the average. If you're looking at the average population, it's a tiny bit under 1. right? That's if we're going to talk about no variation or tons of variation, it depends on the population, hair length, or we're not, just watch a sports performance and you're not seeing 5% variation in talent. Whatever you're looking at, some stuff has 1,000% variation, 1,000,000% variation, right? I mean, some stuff has all the exact same. Should we focus more on clinical significance other than statistical significance? Yeah, so clinical importance. For the question that was asked, should we focus more on clinical significance rather than statistical significance? Report statistical significance in a clinically meaningful way. Clinical significance, talking about magnitude of the effect at the same time, essential if you don't want to look like a fool in 10 years when people are like, oh, the Snicker test stuff. So really good question. And yes, clinical clinical importance, the magnitude that is relevant to a patient population, something like that. So 0.05, that was arbitrary. Fisher just said, 95% sounds good to me. And it hasn't become anything but arbitrary, but Fisher again was the most intelligent, the most brilliant statistician to ever live. And we just accept everything he said as law. But it's not really law in this way. So we should be encouraged by 0.05 outcomes, and especially 0.01 outcomes, and especially by 0.001 outcomes, but we don't just accept them as truth. And people have known this for a long time, and have, in these little publications you can find throughout history, you'll start seeing people 1942, a couple from 1963, these publications saying maybe there's more to it than 0.05. Maybe we shouldn't be such kind of rigid maniacs about the enforcement of the 05 law. It persists. This still persists, and you will encounter it when you submit papers. So you have to be really cautious. And then remember, there's a ton that the p-value doesn't say. The p-value just gives you this very specific probability. But if you're deliberately misusing statistics, or there's error here and there, right? There's confounding variables. This doesn't, the p-value doesn't tell you how well the experiment was done. And so normally, a little bit of a detour here to say how we should do experiments, right? Because the p-value doesn't say how the experiment should be done. It just says significance. But most people, there's a condescending cliche where people say, oh, you're just on a fishing expedition. If you go analyze a bunch of data and just try to find whatever, oh, you're on a fishing expedition. This is the criticism. But if you think about that criticism, it's actually not that critical. That's how we should go about eliciting findings. So I hate cliches, avoid cliches wherever possible. But this one is just, it's not even close to true. As criticism, it's not close to true. So the way we run experiments, the way we optimally should, the way we ought to run experiments is just like fishing, right? Select a body of water. Nobody spins the globe and lands their finger on it and says, oh, the northern hemisphere, mid-Atlantic Ocean or whatever. Nobody does that. You select your lake. I'm going to go fishing. You select a particular lake, right? You don't pick a lake at random. And a region of that lake, oh, this is a little spot I like to go fishing, right? And then you choose the logistics, the context, right? I'm going to go at 6 a.m. The sun's going to be starting to go up. Some bugs will be out. This is the lure I'm going to use. So all of your methodological parameters, right? I'm going to use these types of analyses. I'm going to use this type of sampling to try to get, there's a population of fish and I'm going to use this particular thing to try to sample from it. All of your research methods, you choose in advance. You don't go and just dump them all into the lake. And then once you've chosen your lake and you've chosen your time of day and you've chosen your specific place in that lake and you've chosen the lure and you've chosen all of your gear, you drop your line in and then you reel up whatever you find. Whatever comes up, that's what you get. That's your finding, right? It's a mermaid, it's Nemo, I don't know, whatever you get, you cook it and eat it. And that's how research should be done. What you should not do is pick out a fish ahead of time, Nemo, and then figure out how you caught it. That's not like, oh, this is where I'm gonna, this is where I caught Nemo. And where you don't want to pick out your finding ahead of time. You want to select all of your methods and environment and instruments, and then go forward and just see what you find. That's how you should do experiments. But the p-value that you get doesn't tell you whether you ran a good experiment or whether you ran a corrupt, terrible, error-filled experiment, right? Consider external and internal validity, right? So let's go back to lecture 11, slide 195. This is the review lectures. I could have picked a different lecture, but this is the PDF that you have. So internal validity, soundness of your methods. External validity, can you generalize? What's the, if you test half the world, you get to generalize to the rest of the world pretty effectively. If the only people you're testing are exactly 13 years old and they have cleft palate and a clubbed foot, and they're trying to exercise for the first time, and they're this particular sex and ethnicity, and you can't generalize. You can only talk about that exact group. So that's external validity. So consider that stuff. Now, in general study design, significance, the statistics are going to give it to you, and is going to be a perfect number, a perfect, beautiful output for what could be a horrible experiment, right? Because statistics they don't exist in nature, right? This is human intervention. There's no other way to get statistics but human intervention. We handle those numbers over and over and over, and in doing so, we mold them, right? So we manipulate things. That's the nature of statistics, is manipulation. And we can manipulate effectively, right? Or we can manipulate deceptively. And so let's go back to 11 slides ago. The deliberate misuse of statistics and inevitable sources of error of just people making mistakes. P-value doesn't say anything about these. It doesn't tell you whether the people ran a good experiment or if they were biased along the way. So in some cases, in some circumstances, statistical analyses are wonderful, and they're clear, and there's no bias, at least as bias is managed as much as possible. I don't know if there's ever no bias, but it's managed the best it can possibly be managed. And in other cases, many, many other cases, I don't know if it's the majority of cases, but if it's a minority of cases, it's a thick minority. You see these researchers just bending over backwards trying to get their statistics. I mean, they put it in an arm bar and just bend it until it taps out and yields its findings, sort of the Cirque du Soleil of statistical findings. I mean, so much bending and gymnastic work to make it yield the finding that you were hoping for. That's bad. Never do that. That's terrible, right? So what you want to do is be an honest statistician. And then sometimes you'll find true things, sometimes you'll find false things, and it's totally fine to publish false things if you did the experiment correctly and your hunch is maybe it's true. Totally fine. I'm sure I've published lots of false things. You can't know that until people rerun experiments. You can't know. What you have to do is test things honestly. You can't do the gymnastics with it, right? You can't be a contortionist and make your statistics yield the finding you need them to yield, right? That's unethical. What you need to do is find what you find and publish it. And maybe it's true, maybe it's false. It ceases to be yours. You stop owning it at that point. You literally stop owning the words. The journal actually owns your words. So you can't, if you copy and paste those words, it's plagiarism. You can get in trouble for that, for copying and pasting your own words, because you don't own them anymore. But the world owns that finding at that point. Just like when a musician releases a song, oh, it's about this or that, and here's what it means. Whatever. Nope, the world gets to decide what it means. It doesn't mean that to them, and you don't get to tell them what the song means, right? It stops being yours. It becomes the world's. It becomes the audience's. Same thing with statistics. Once you publish, it's no longer yours, literally and figuratively. The world gets to decide whether it's true, and that's totally fine, right? I mean, have thick skin. People are going to say, oh, that's wrong and whatever. And like, fine, maybe it's wrong, maybe it's right. Ideally, you're right most of the time. Totally fine. Now, GIGO, right after I said, let's avoid cliches as much as possible, fishing expedition. This is a really valuable thing to consider. Now, I'm going to tell a story here about one of my research projects. Will somebody tell me how much time I have left, of how much I can indulge this story? So I'm going to tell a little story that will illustrate the importance of GIGO, which means garbage, 20 minutes, thanks. Garbage in, garbage out. Now, if you everyone understands this from the kitchen perspective, right? You have ketchup and chocolate and kale and ground up powdered flour, like wheat or something. Um, okay, go make a delicious thing out of that. Use all 4 of those and make a delicious dish. Impossible, right? Okay, here's your ketchup and peanut butter sauce that you can put on your like this doesn't, it's going to be horrible, it's going to be terrible, right? If you're putting garbage or it's just all spoiled, I could put chunky sour terrible milk into, there's, if you've seen The Office, like my sour lemon milk or whatever, Kevin's line of horrible spoiled milk. If you put that into your recipe, I don't care what else goes in there, it could be the best tasting stuff in the world, and it's going to be disgusting because you're putting garbage ingredients into the perfect recipe, right? Garbage in, garbage out. It's the same thing with science. And now I'm going to make fun of a study and some authors who I respect. I respect these people. I know all of them but one. I have no idea who this person is. She died a couple of years ago and was a massive, massive researcher at UConn. She was the youngest person ever to get tenure there. I mean, world-renowned, massive research, and she was like a foot tall. I thought the first time I met her, I thought she was going to be 10 feet tall. She's such a giant in research, and then I met her, and she looks like a hobbit. So these are great people. Jeremiah Weinstock, Sheila Lessie is still there. Kevin Dekows, he's an MD at UConn. But this was a study that I worked on. If you're going to graduate school in a research capacity, not like a teaching labs, like a teaching assistant, that's mostly what we do here is teaching assistant. But if you go into a PhD, it's a research assistant, and you go collect data and work with the study. And I worked with this study. Now they published this, and what they're looking at, contingency management. We pay people to exercise, and does that help them get off drugs, right? There's a bunch of HIV positive people, they're sharing needles, or on drugs, and can we get them to exercise better, healthier behaviors if they are exercising? Can we get them to practice better behaviors, is a better way of saying it, if they are physically exercising? And this was a good study right here, what they published off of it, looking at number of consecutive negative drug testing samples. Okay, yeah, sure, the contingency management people worked for a little while. I have some qualms about contingency management. I really don't think it's good in the long run. I think it's great acutely, and chronically I have problems with it, but I'm not saying I'm right. That's just my perception of it, but somebody who worked in the field for a while. But okay, so they saw that, and then they saw viral load, right? So the contingency management group was reducing their viral load. Remember, these are HIV positive patients. And then they said, all right, here's what we need to do. I want to look at, this is them saying, I want to look at how much people exercise, how many calories are they burning? How many hours of exercise are they getting in? And let's quantify the intensity and calories that they're burning, and then see if that affects. So more intense exercise equates to an even better, smaller viral load, and more intense exercise equates to even better outcomes. So they asked me, I was a research assistant. That's how I was paying for my tuition. They asked me, go figure out all these data. And I have all these sheets of paper that everybody filled out about what they do for exercise, what all of these subjects do for exercise. And they're assigned things, and then they complete them, or they don't complete them. But I have a little check next to the exercises they did complete, and I'm supposed to quantify the number of calories they burned. So they fill out this thing called the Paffenbarger questionnaire, really common questionnaire. How much do you walk? What physical exercises do you do? How many flights of stairs do you walk into? It's a bunch of qualitative sort of stuff of you're asking these questions, and you quantify it. But so if somebody says, I ride my bike, okay, well, what kind of biking? You have to follow up with a bunch of questions. Well, are you mountain biking? Is it just general stuff? Is it competitive? Are you doing some vigorous uphill thing? There's a different number of METs to assign it. Metabolic equivalent of the task. So a MET value of 1 means your basal metabolism. You're lying in bed, you're watching TV, you're reading, you're sleeping. You have a MET value of 1. A MET value of 2 means you're twice that, your metabolism, you've doubled that. MET value of 14 means you're like 14 times your resting metabolism. We're really ramping things up here. Now, the Ainsworth Compendium, this comes out every decade or so. 1993, 2000, 2011. This is the 2011 one. I'm unfamiliar if there's a newer one. Last time I looked, there wasn't. but tons of bicycle entries, tons of unicycling. I mean, it's just everything, every verb you can think of is going to appear in the compendium, in Barbara Ainsworth's compendium of activities. And then you can figure out, don't do this, don't do the math, but you can figure out how many calories they spend in an activity. If you know the MET value and the number of minutes, you can do the math and figure out how many calories. I don't think anybody's from the armpit to kicking the basketball. Well, you'd have to figure out how they're doing that. But these, I'm copying and pasting here. These are examples of what exercises might look like that I had to code. I'm given a bunch of papers and said, here's exercises that the exercise group was doing. There's a non-exercise group and there's an exercise group. Here's what the exercise group was doing. Now, I copied and pasted these from different people. This isn't a single person's 6 weeks, but I copied and pasted these. This is a collection of actual quotations. I manipulated nothing here. I changed nothing. The typos are the typos that were there. These are the pages I was handed. So let's look at what I had to code. 15 arm lifts. How many calories is that? What the hell does that even mean? 15. They just went like up and down, like trying to fly for 15 seconds. 39 arm rolls each hand. Okay, again, this feels like something that takes 10 seconds. 15 toe taps. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If that's 1 calorie, I'll be stunned, right? Walk at least 4,000 steps on a 2-day. I don't know what that means, right? Is that like shorthand for today? On today, or is it 2 days during the week, or is it Tuesday? I don't know what that means. How am I supposed to code for that? Sitting, lever, leg, 10 movements. There's an exercise machine in the clinic. I made an assumption that they used that and did 1 set of 10 reps. That was my assumption. I coded for that. Bike cycling, 15 minutes. Okay, I can do that. I assume they're bicycling, right? And I did general bicycling for 15 minutes and got the number of calories. Swim at least 30. 30 what? What's the unit of measure here, right? I mean, 30 minutes, I'm guessing, but I mean, 30 laps, 30, miles. What are we, and at least is a little exercise at the Y treadmill. How much exercise did you do? I don't know how to code this. How many calories did you burn? Walk it says. Okay, I'm just gonna put down 100 calories. I had no idea. 2 workouts, no idea, right? Now this one said walk 87,000 steps one day. Okay, now remember, these are HIV positive patients. They have lipodystrophy. They have, some of them have muscle wasting, and you can figure out, I turned to the literature. I was doing this the best that I could. Garbage in, garbage out. I did this the best I could. I went to the literature and figured out how many steps were in a mile. And for a particular sex and height and whatever, and it was 45 miles in 1 day walking for a person with muscle wasting. I don't think so. I think I coded that was like 8,000 steps, and like there had to be a typo. Physical activity sheet. I don't know. They filled out paperwork. I'll give you 5 calories for that, right? Sit PS with Mike. I know Mike and Harold. They're both wonderful. Mike Bruno. They were also with me at the. They were the other 2 GAs. Mike is a professor at Drexel in Philly, and Harold is currently doing his postdoc at Harvard. These are wonderful people. Walk 20 minutes on Mike or Harold. Man, I feel sorry for Mike and Harold, right? But I assume they meant with. 30 lower resistance or walk, bike or stretching, Zumba or Stairmaster. What did they do? I don't know. Or doesn't make any sense, right? The light was green or red. So I went, right? Or I can't code an or, right? Wear my pedometer for 4 days. Tell me what the pedometer said, and I can code how much it was. Talk a walk to Bushnell Park. Now this is Bushnell Park. And if they're taking a walk to Bushnell Park from California, that's 3,000 miles away. I don't know what their starting point is. This is in Connecticut. Walking war, 5 out of 7. I looked it up. What the hell is a walking war? I got like, I don't know what that is. It looks like maybe Korean. I don't even know. Like I did Japanese in high school and undergrad. That was my language of choice. And this, I don't recognize any of that. So I don't think this is Japanese. I don't know what to. I don't know how to code this stuff, right? 150 steps on a stepper, I can do that, right? But I calculated it was 17.64 calories. I went to the manual, I figured everything out. It took me like an hour to code 17.64 calories. Why perform the exercise at all? Why don't the toe taps and stuff? Why do that? So the point of all this, GIGO. You can't publish that because it's garbage going in. Did I give them a calorie number, a daily calorie number for every single subject in the study? Yes, I did. It took me like 2 months of full-time work to do it. Is that valuable? information? Not in the least. It's like dangerously unvaluable, because if you analyze that, it's gibberish. Garbage out. You're giving me ketchup and peanut butter and asking you to make a delicious pudding. You can't do it. It cannot be done. So garbage in, garbage out. Now, garbage in, garbage out today in popular media, right, is who's going to win? Who's going to win the election, right? Okay, is it going to be Biden or is it going to be Trump, right? Well, who's the candidate for the Democratic Party? Whoever is thought to beat Trump, right? Biden is the one who seems to have the best odds at beating Trump. If the world were populated by teenagers, it would be Bernie Sanders. But it seems to be Joe Biden. It seems to be the guy who has the best likelihood of beating Trump. Okay, but look what happened with Hillary and Trump. Look at all of these. I mean, this is just Google it, of what all the predictions were ahead of time. Hillary was supposed to just destroy Trump. And how did Trump win? Did he win with karate? Right? How did he win? It's pretty easy to answer these questions because all you have to do is look at history. Now, this is I'm not going to ask about that UConn study, but do understand what garbage in, garbage out means. And that's the best way that I can explain it to you is a narrative. I will definitely ask you about contexts of garbage in, garbage out. I'm not going to ask about that, particular story. But presidential election, 1936. We have Roosevelt, right, the incumbent. This he won in 1932 with his "Happy Days Are Here Again" slogan. It sounds a lot like MAGA, right? Make America Great Again. Happy days are here again. But he won from Herbert Hoover, who we had 20% unemployment in the U.S. I wasn't alive, but the U.S. they had 20% unemployment, and then Roosevelt just destroys him. Roosevelt depends what state you're from. If you're from Texas, it's Roosevelt. And then he's going against Alf Landon in 1936. Now, Alf Landon, he's this Kansas governing oil tycoon, and so we have our Democrat and our Republican, right? We have our Biden and our Trump. And the Literary Digest did a mock ballot, right? They sent out 2.3 million mock ballots that they tabulated. There aren't that many people. There are 128 million people alive, and that's like counting babies who aren't voting, right? There aren't that many voters in the US, and they got 2.3 million Americans to cast a mock ballot of who's going to be president. They published it on Halloween that year. That's what the little ghost is about. And what they decided was that Alf Landon, right, he's going to win by a landslide, 370 to 161. The US, Alf Landon is our guy, right? And then just like 3 days later, after this thing comes out, it was the most lopsided election in presidential history. I don't know, like after the first, whatever, Washington. We have the most lopsided election in Washington was like a king in presidential history. This has never happened since. It never happened before. And every single time, look at the blue map, right? Every single state, except for Vermont and Maine, it was 523 to 8. But they had 2.3 million votes a few days before that they reported. The problem was called representative sampling. Write that one down. Representative sampling. The mailing lists for those mock ballots were people who were telephone subscribers and automobile owners. That's how they got these addresses. Now, telephone subscribers and automobile owners, these people are not struggling in the Great Depression like everybody else. Remember, the world had just been handed off from Hoover. Remember, Hoover flags are like you hold out your empty pockets. The dollar goes nowhere, and everybody's dying of poverty, and the world is horrible. At least the U.S., but it was sort of a global effect when the economy and the stock market crashes. That's not like a local, only New York is affected. And so they generate these lists and they send them to rich people, right? They send the ballots only to rich people. That's not representative of the other 42 million voters who are going to cast their ballot. So sample size is helpful, but sample selection, it has to be generalizable. It has to be representative of the people. Obviously, all of the rich people did vote for Alf Landon, but everyone else voted for Roosevelt. And so understanding how, best practices, who are they testing? For best practices, for all it's PT, it's orthopedic something, what's the sample population they're working on? Usually it's a bunch of college students, because that's who we have research access to. all right, fine, I'll give you 5 points extra credit if you join my study. We all do that. I've done it. Everybody on campus does it. 5 points extra credit for joining a study. Should I do that? Is it ethical? I don't know. Probably not. Maybe I should only volunteer if you want. Okay, sure. Yeah, that's more ethical. Well, we got to find subjects somehow, and I'm not perfect, right? I'm not the most ethical guy anyone's ever met. And so we all breach representative sampling. I mean, we all, I'm sure there's some people who are just saints with this, but very few saints in the world, statistical saints. And so representative sampling is something we have to admit and we have to consider. Now, I will always admit my sampling. If I have weird sampling in a particular experiment, I'll admit it so people know what the limitations are. But we can't be sneaky with that stuff. We have to be really cautious with how we sample people and what we do with those samples, right? How we record information, garbage in, garbage out stuff. Okay, that's all. What do we have for, does anybody have poster questions, content questions, any whatever assignment questions?
Just to make sure, when are office hours again?
Right after today, but it's always hard on Monday to get to them right away. So I usually stay late. So for Monday's office hours, don't hop on right at 4:15, whatever, 3:15. What the hell time is it? 3:15. Don't hop on right at 3:15 because people stay after 1:47 and ask me questions for like 20 minutes. And I'm in the middle of office hours and I'm still on that call, just like this. People would potentially stay after, but I get a lot of questions after 1:47, and it cuts into office hours. And then as soon as I stop this lecture, my computer freezes for like 10 minutes to export the file, and I can't log into the next thing. So if you join Monday's office hours, join at after 3:30, and I'll stay late if you do that. Otherwise, Wednesday before class for the hour leading up to class.
Okay, thank you. Goodbye. Thank you.
I assume nobody else has any questions. All right, I'll see you guys in a couple days.